3 years ago, a volcano in eastern Russia collapsed, and its ash reached the west coast of North America. Alaska Airlines canceled more than 24 flights. Air Canada grounded service into British Columbia. That volcano is Sheveluch, and it is erupting again right now on a 4-day cycle for 3 weeks. The structure that produced the 2023 collapse has been rebuilding ever since, and it is already taller than the dome beneath it. By the end of this video, you will know why the ash heights in every headline are the least useful numbers in this story. A volcano on the far northeastern edge of Russia has now erupted 6 times in 22 days, and the most recent column went to 40,000 feet. That advisory came out of Anchorage on Monday at 17:58 Universal Time. It described an ash plume extending from the ground surface all the way to flight level 400, 40,000 feet, roughly 12.2 kilometers above sea level, drifting southeast at 80 knots. It also carried a note that a portion of the ash was obscured by meteorological clouds, and that note turns out to matter more than the height. The volcano is Sheveluch, sometimes spelled Sheveluch, on Russia's Kamchatka Peninsula, one of the largest and most active volcanic structures in a region defined by large and active volcanic structures. And what is happening there right now is not a single dramatic eruption. It is a rhythm. Count them out. The 29th of June, ash to 33,000 feet. The 3rd of July, 34,400. The 5th of July, 39,400. The 8th of July, 23,000. The 16th of July, 23,000 again. And then Monday, the 20th of July, 40,000 feet. 6 advisory-level explosive events in 22 days, an average interval of under 4 days. Now, here's the part most coverage gets backwards. The headline number in every one of those bulletins is the column height, and the column height is the least informative number in the story. It tells you an explosion happened. It does not tell you what the explosion did to the thing that produced it. Sheveluch does not erupt out of an open pipe in the ground. It erupts out from under a structure. And the question worth asking is what those 6 explosions have been doing to that structure. To understand why the cadence matters more than the altitude, you have to understand what kind of volcano this is. Sheveluch produces andesite. Andesitic magma is viscous, thick, sticky, resistant to flowing. When it reaches the surface, it does not run downhill and spread out the way basaltic lava does in Hawaii or Iceland. It cannot. It is too stiff. So instead of draining away from the vent, it piles up directly on top of it. What accumulates is called a lava dome, and it is one of the strangest and most dangerous structures in geology. The outside of the pile chills against the atmosphere and hardens into a rigid shell, a carapace of solid rock. The inside stays extremely hot and stays charged with dissolved volcanic gas because the shell traps it there. So what sits over the vent at Sheveluch is not a mountain in the ordinary sense. It is a pressurized, gas-rich mass of semi-molten rock, held in place by nothing but its own outer crust and its own shape. That structure gets more unstable as it grows. Every new batch of magma pushed up from below makes the pile taller and steeper. Gravity works on it constantly. The carapace fractures. Blocks break loose off the flanks and tumble down as hot avalanches. And the whole time, the gas inside is still trying to get out. Sheveluch has been doing this without a break since August of 1999. 27 years of continuous eruption. The Global Volcanism Program describes the current period as consisting of lava dome growth, explosions, ash plumes, and avalanches, the 4 things that always go together on a volcano built this way. So when 6 explosions happen in 22 days, the relevant question is what those explosions did to the pile of pressurized rock sitting over the vent. The answer is honestly unknown right now. But there's one measurement that makes the question urgent rather than academic. At the end of December of last year, a new lava dome began extruding on the western part of the existing dome complex on the crater floor of young Sheveluch. That is documented in weekly reporting from the Global Volcanism Program. By the end of February of this year, 2 months later, that new dome was higher than the young Sheveluch dome it was growing on top of. I read that again because it is the single most important structural fact available about this volcano. A brand new extrusion, roughly 7 months old, has already grown taller than the body it is sitting on. And it did that in about 2 months. Rapid vertical growth of a viscous extrusion is precisely the geometry that produces gravitational instability. You are stacking heavy, hot, fractured rock upward on a base that is itself a pile of heavy, hot, fractured rock. The taller it gets, the steeper it gets, and the more of its own weight rests on material that was never built to carry it. So the 6 explosions of the last 3 weeks are not happening on top of some stable old remnant that has been sitting there for decades. They are happening on top of a structure that is actively and rapidly enlarging. The system is being loaded from below at the same time it is being shaken and undercut from the sides. And there is direct evidence the loading has not stopped. Satellite imagery through June showed a daily thermal anomaly at the dome complex, which means fresh material is still arriving at the surface. The extrusion did not pause when the explosion started. Both processes are running at once. That is the setup. A rapidly growing dome, continuously supplied from below, being repeatedly explosively decompressed from within, on a volcano whose documented behavior is to build something and then destroy it. Watch how the agency responsible for this volcano behaved in the first week of July, because the pattern in their own alert level is telling you something. Kevert, the Kamchatka Volcanic Eruption Response Team, runs an aviation color code. On the 3rd of July, at 21:56 Universal Time, they raised it from orange to red. Red means an eruption is imminent or underway with significant ash emission into the atmosphere. 5 hours later, at 2:58 on the 4th of July, they lowered it back to orange. No further ash explosions had been observed. Then on the 5th of July, at 07:36 Universal Time, they raised it to red again. Then on the 6th of July, they lowered it to orange again, while noting that explosive extrusive eruption was continuing. Red, orange, inside a single week. That is not an agency being indecisive or overcautious. That is an agency accurately tracking a system that is genuinely switching states on a time scale of hours. Pressurize, vent, quiet down, pressurize again. And on the 5th of July, the day of the second red, the eruption produced something worth pausing on. Video observations confirmed an explosion lasting roughly 10 minutes, with ash reaching 12 kilometers, 39,400 feet. The resulting cloud measured about 222 kilometers by 45 kilometers, and it positioned itself directly over Elizovo Airport and the city of Petropavlovsk-Kamchatsky. That is the regional capital and its main international airport, sitting underneath a volcanic ash cloud 138 miles long. This is not a remote wilderness event. It has already put ash over a functioning airport this month. And it gets worse, because the standing warning Kevert has maintained throughout is that ash explosions to 12 kilometers could occur at any time, with no further notice, and that ongoing activity could affect international and low-flying aircraft. Here is where the story turns from a volcano problem into an observation problem. The first aviation message for Monday's eruption did not confirm an eruption. It described the event only as possible. The reason was simple. Thick meteorological cloud was sitting over the summit, and nobody could see whether anything had actually happened. Roughly 2 hours later, imagery from the Himawari 9 weather satellite showed volcanic material moving continuously away from the volcano. That confirmed it. An eruption had occurred. But notice how the confirmation arrived. Not by looking at the volcano, but by looking at what had already left the volcano and traveled far enough to emerge from under the cloud deck. The Anchorage advisory for the 20th carries the annotation in plain text. Some part of the volcanic ash, obscured by meteorological clouds, so satellites can track the ash once it separates and drifts clear. They cannot see through weather cloud down to the dome itself, and the dome is the only thing that would answer the question this entire situation poses. Column height tells you an explosion released, stored pressure. It does not tell you how much of the dome moved during that release. It does not tell you whether fractures are propagating through the interior of the structure. It does not tell you whether the flanks are deforming outward, or whether fresh magma is now rising faster than it was in June. The confirming instrument and the diagnostic instrument are not the same instrument. Himawari 9 confirmed that ash left. Nothing currently available is watching the mountain. And reporting indicates a cyclone approaching the Kamchatka region, which, if the forecasts hold, makes the visibility problem worse rather than better. Treat that storm as reported rather than confirmed. Independent verification of a specific named system in this window was not obtainable, but the cloud cover that is already blocking the view is documented in the advisories themselves. You need to understand what failure looks like on a volcano like this, because it is not what most people picture. When a large section of a lava dome collapses, the confining load on the gas-charged magma underneath it is removed, not gradually, but on a timescale of seconds. Dissolved volatiles that were held in solution by that pressure come out of solution all at once and expand explosively, fragmenting the magma into ash and rock. But here's the critical part. Because the confinement was removed from the side, the resulting blast is directed to the side. It does not go straight up in a tidy column. It goes outward and downward, and the collapsing dome material gets entrained into the expansion. What that produces is a pyroclastic density current, a ground-hugging flow of hot gas, ash, and rock fragments that travels at highway speeds and hugs the terrain. You cannot outrun it. You cannot shelter from it in any ordinary structure. This is the mechanism that destroyed Saint-Pierre on Martinique in 1902, which is why the eruption class carries the name Palaeon. That is the difference between what Sheveluch has been doing for 3 weeks and what Sheveluch is capable of doing. A 12-kilometer column from a 10-minute explosion is a vertical release. A dome collapse is a lateral one, and it releases vastly more energy. Consider the scaling. Column height goes roughly with the fourth root of thermal power, so a plume reaching 20 kilometers instead of 12 does not represent an eruption 1.7 times more powerful. It represents one on the order of 7 to 8 times more powerful. Treat that as an illustration of the scaling rather than a measured figure. But the gap between what is happening now and what a collapse would produce is enormous. And we know exactly what that looks like at this volcano because it happened 3 years ago. At roughly 00:54 local time on the 11th of April, 2023, the lava dome at Sheveluch collapsed to the south. What followed was the largest eruption at this volcano in approximately 60 years. The plume reached roughly 20 kilometers altitude. The ash cloud spread over approximately 108,000 square kilometers. The village of Kluchi, 50 kilometers to the southwest, received about 8.5 centimeters of ashfall, enough to collapse roofs, foul water, and shut down a community. Post-eruption satellite analysis classified it as Palaean. Dome collapse, lateral blast, exactly the mechanism just described. And when it was over, the dome was gone. In its place was a caldera measuring roughly 2 kilometers by 2.6 kilometers. That is the scale of material that came off the mountain in a matter of hours. Now hold that against the current situation, because the connection is the whole point. 2023 is the only direct evidence available for what happens when this specific dome on this specific volcano resolves the exact configuration that is present right now. It is not an analogy borrowed from somewhere else. It is the same structure, the same magma, the same geometry 3 years ago. And the aftermath is arguably more unsettling than the eruption. A Global Volcanism Program figure caption dated the 30th of May, 2023, roughly 7 weeks after the collapse, documents a growing lava dome already forming inside the brand new crater. 7 weeks. The largest eruption in 60 years destroyed the structure, and within 7 weeks, the volcano had started building the same hazard again in the scar left by the last one. That regrowth is what has been going on ever since. It is the thing that has now, as of the end of February, grown taller than the dome underneath it. The dome that is currently erupting every 4 days is the child of the 2023 collapse. Step back and look at the record, because this volcano has a documented habit. The Global Volcanism Program credits Sheveluch with at least 60 large eruptions during the Holocene, roughly the last 10,000 years. That averages out to one large eruption every 165 years, though the distribution is strongly clustered rather than evenly spaced, so the average is a bookkeeping figure rather than a schedule. More useful is the modern record. In 1964, a major south flank collapse during a Plinian explosion destroyed the dome complex and left a scarp behind. A new dome, young Sheveluch, began forming inside that scarp in 1980. It grew for 4 decades, throwing off ash plumes, pyroclastic flows, and spine-like extrusions in 1993 and again in 2020. And then in April of 2023, it collapsed. 1964 and 2023, 59 years apart. The pattern is not subtle. Build a dome, destroy the dome, build another dome in the crater left by the last one. Frequent collapses of dome complexes have produced debris avalanches whose deposits cover much of the floor of the breached caldera. That is the official description. And it means the ground around this volcano is largely made of the wreckage of its own previous structures. None of that is a prediction. Nobody has issued a warning of imminent dome failure. There is no basis for saying 2023 is about to repeat. And the honest reading of the current data is that Sheveluch is doing something well within its normal range. But it does mean this. A volcano with an unambiguous, repeatedly documented failure mode is currently sitting in the configuration that precedes that failure mode. A rapidly growing dome, continuous magma supply, repeated explosive decompression, while the one measurement that would tell us which way it is trending is blocked by weather. That is not a reason to panic. It is a reason to pay attention, and it is also the reason this stops being a Russian problem. Volcanic ash is not smoke. That distinction is the entire aviation hazard. Smoke is soot and unburned carbon. Volcanic ash is pulverized rock and volcanic glass, hard, abrasive, angular particles with a melting point well below the operating temperature inside a jet engine's combustor. So here is what happens when a jet flies into it. The engine ingests the ash. The particles reach the combustion section and melt, then move into the cooler turbine section and resolidify onto vanes and blades in a glassy layer that disrupts airflow. The result can be thrust loss or a full flameout, every engine shutting down at cruise altitude. Meanwhile, the ash abrades cockpit windows until they are effectively opaque, contaminates the pitot-static sensors the aircraft uses to measure airspeed, and gets into bleed air and ventilation systems. And now the part that makes it genuinely difficult to manage. Aircraft weather radar cannot see it. Radar is tuned to detect water droplets, and it does not reliably return volcanic ash. Ash is also effectively invisible at night, and it can hide inside ordinary meteorological cloud, which, given that meteorological cloud is exactly what has been sitting over Kamchatka, is not a hypothetical concern. That is why volcanic ash is managed by advisory and avoidance rather than by onboard detection. Pilots are not expected to see it and steer around it. They are expected to be told where it is and stay out of that airspace entirely, which requires the advisory network to know where it is in the first place, which brings us to what happened to Monday's cloud after it left the mountain. On the 16th of July, the ash cloud from Sheveluch was logged by the Tokyo Volcanic Ash Advisory Center at flight level 230. On the 20th of July, the advisory came from Anchorage. That handoff between advisory centers is not a bureaucratic detail. It is the marker that the material had stopped being a regional Russian problem and entered the North Pacific Corridor, the airspace that carries traffic between North America and Asia. And the transport numbers explain how fast that happens. Monday's cloud was moving southeast at 80 knots. That is 148 kilometers per hour, about 92 miles per hour. At that speed, material covers roughly 3,550 kilometers in a day. The great circle distance from Sheveluch to Vancouver is on the order of 6,000 kilometers. Do that division, and you get a transit time on the order of 2 days. That is not theoretical. It is consistent with what happened in 2023, when material from the April collapse crossed the North Pacific and reached the west coast of North America. Air Canada canceled regional flights to and from Prince Rupert and Terrace in northwestern British Columbia. Alaska Airlines canceled more than 24 flights within Alaska, citing the risk of engine shutdown. Some carriers rerouted eastbound departures out of Vancouver when the cloud arrived. Transport Canada, NAV Canada, and the Montreal Volcanic Ash Advisory Center coordinated the monitoring. The overall impact on Canadian carrier operations ended up limited. But the precedent is established and it is not in dispute. A dome collapse at Sheveluch produced operational disruption in Canadian and Alaskan airspace from the opposite side of an ocean. There is a version of this hazard that is worse than a single enormous explosion, and it is worth being precise about it because it connects directly back to the cadence. The most consequential aviation scenario is not necessarily the largest event. It is a second powerful explosion injecting material into the same eastward wind corridor before the first cloud has had time to disperse. Discrete pulses produce discrete clouds, and discrete clouds dilute, spread, and eventually thin out to concentrations aircraft can tolerate. The advisory system is built for that, but sustained, overlapping injection produces something different, a continuously contaminated corridor, fed from the upstream end faster than the downstream end can clear. Now, look at the cadence again. 6 events in 22 days, an average interval under 4 days, and a transit time to the North American coast on the order of 2 days. Those two numbers are uncomfortably close together. A 4-day eruption interval and a 2-day transit means the system is currently just barely producing separable clouds. Shorten the interval, or produce one event large enough that its cloud persists longer, and the separation goes away, which loops directly back to the dome. A bigger corridor problem requires a bigger source event. The only thing at Sheveluch that produces a meaningfully bigger source event is the dome failing. The aviation exposure over the North Pacific is not a separate hazard from the structural question in Kamchatka. It is the reach of that hazard. And one claim circulating online deserves a direct answer. The storm approaching the region did not trigger these eruptions. Atmospheric pressure changes do have a small documented influence on already critically poised systems, but they operate on the order of a few hectopascals against magmatic pressures measured in megapascals. Sheveluch has been erupting since 1999 and explosively throughout July, before any storm approach. What weather can do is redistribute what the eruption already produced. Rain on fresh ash and pyroclastic debris generates lahars, which need no eruption at all to start. That coupling is real. Causation in the other direction is not. So what should you actually be watching for, and what would tell us which way this is going? Not column height. That is the number every headline leads with, and it has been range-bound for 3 weeks. 10.1 kilometers, 10.5, 12, 7.7, 12.2. No upward trend. If the dome were catastrophically degrading, that is not necessarily how it would announce itself. The meaningful indicators are different. A step change in seismicity beneath the dome, measurable deformation or inflation of the dome flanks, a marked increase in the frequency or run-out distance of hot avalanches, a sustained rise in thermal output indicating the extrusion rate has accelerated, and above all, duration. The 5th of July explosion lasted approximately 10 minutes, Duration, not height, is the variable that separates a discrete pressure release explosion from a sustained eruption being fed by a failing structure. An event of similar height that lasted several hours instead of 10 minutes would be a categorically different signal, and it would change the assessment immediately. There is also a simpler thing to watch. Does the aviation color code go back to red? And if it does it hold? It is sat at orange since the 6th of July, despite continuing explosive extrusive activity. A return to red that persists for more than a few hours, rather than reverting within the same day the way it did on the 4th, would be the clearest public signal that Cavort's own assessment has shifted, and the one that resolves everything when the cloud clears enough to see the dome. The first clean optical or radar look at that structure, specifically at whether the December extrusion is still growing and whether new fractures are visible on its flanks, is the observation that answers the question this whole situation poses. Until that look happens, both readings stay on the table. The explosions are either venting the system safely or dismantling it a piece at a time. They produce identical satellite imagery. Satellites can watch the ash leave. They cannot watch the mountain. We will be tracking the advisories out of Anchorage and Tokyo, and we will tell you the moment that view opens up.